Welcome, ladies and gentlemen, to the video lesson for 6.1 on slope-intercept form. I hope all of you are having a wonderful day, evening, early morning, whenever you're watching this. Before we go any further, it's a little bit about what this lesson is. This lesson is probably one of the more important lessons that we'll do all year. It's really important that you pay attention to what everything in this video is. Slope-intercept form finds its way into just about every mathematics class that you'll take. In the high school. In some form or another, you're going to probably see it again. So just make sure that make sure you get to a certain point in this video or in the class lesson where you feel like you're really confident with what slope-intercept form is and how to use it. All right, so the first thing we're going to review are things about slope and y-intercept, okay? So remember, slope, if we want to do like a casual definition, that's like our rise over run. Right? Our slope, I'm going to get a little bit of a thinner marker here. It's our rise over run, okay? And we had a formula for that, which we could say is then equal to the y2 minus y1 over x2 minus x1. And so that was our slope formula for finding slope. So this one we used on the graph where we literally just counted how far did I go up or down, how far did I go to the right. This one, if I just gave you 2 coordinate points, you'd be able to figure out the slope. All right, y-intercept, what is that? Remember, that's the place on the graph where a line would cross the y-axis, okay? So I'm just going to make a dot here, and then I'm going to draw a line. So if this was a graphed line, the y-intercept would be right there, okay? So across the y-axis. It always has the form of a number, a 0 comma a number. Redo that. 0 comma some number. And that's because you cannot go left or right, and you can only go up or down if you're going to be on the y-axis, right? And so we're going to actually use this to our advantage later in class. The fact that 0 is a y-intercept here, we're going to use that later. All right, here we go. Slope-intercept form. We're just going to get right into it. What is slope-intercept form? It says here that if a line has a slope of m and a y-intercept where we have 0 comma b, or we said before 0 comma a number, right? B and the number are the same thing here. It says then the line is described by the equation y equals m x plus b. Now I'm just going to rewrite that a little bit larger. Y equals m x plus b. Right off the bat, what we need to understand is that in this equation, m represents the slope, okay? And b represents the y-intercept. And so those are really the only 2 things that I need to graph a line. I need basically these things. I need a place to start graphing, and I need to figure out how I get to my next point. And then I just repeat that process of finding the next point over and over again. If I get enough points, then I graph a line, right? So the starting point is always the y-intercept, right? That's our start. That's where we're always going to start graphing. And this, the slope, we are going to use rise over run directions in order to find the next point from our starting point. All right, so let's see this in practice a little bit here. It says graphing from slope-intercept form. So this is kind of where we've evolved from, right? Very first part, we'd give you an equation like this. We'd say, all right, well, here's a table, and here's a bunch of x values. Substitute those x values in, and then graph them, right? And we're like, well, that's really annoying. Let's use the intercepts methods where we knew the fact that 0 for one or the other x-intercept, y-intercept, we'd substitute in, and we get a point. Now, using slope-intercept form, I'm going to write it again here, y equals mx plus b. Using this, I don't have to really do any calculation when I graph, okay? Remember, this, again, is the slope, right? This is my y-intercept. Well, now if I look at this equation, I obviously don't have an m and a b. So it's like, well, how do I know which one is which? Well, the slope is always attached to the x. No matter if it comes first or second, it doesn't make a difference, right? So that means that my slope equals 5. And I'm always going to turn that into a fraction, so then I know my rise over run, okay? My y-intercept is always the number that is all by itself. okay? And that's going to be this value here. Notice the same thing here, right? It's a number all by itself. The thing about this, though, is that, look, slope-intercept form has plus b, and this says negative or subtract 4, right? So we have to actually change this to add the opposite. So now my y-intercept is pretty clear as negative 4. Well, what does that mean? My y-intercept is really 0, comma, negative 4, okay? That's the y-intercept. That's the point where we start. So now when I go and graph, my starting point is my y-intercept. This is where we start. 0, negative 4, 1, 2, 3, 4, and that's my starting point. Now I use my slope with my rise over run directions to find the next point. My slope is 5 over 1, so that means I go up 1, 2, 3, 4, 5 to the right 1. And I keep doing this 1, 2, 3, 4, 5 into the right 1. And I actually run out of space here 1, 2, 3, 4. And I can kind of estimate where this one goes. And that's how I create my line. Now, if I had anything that was, if I instead graph this point like way over here, it'd be a self-check, and obviously that's not right. So that's not the case. The other thing is like, well, this is only part of the line. What about over here? Well, instead of going up 5, right 1, up 5, right 1, I have to use it exactly backwards, right? So I have to go down 1, 2, 3, 4, 5, and then left 1, and now it's still in line. I'll try to draw the straightest line. Oh boy, straightest line ever. And there we go. Okay. So the thing about this equation, excuse me, is that it was already in slope-intercept form, right? So again, I'm gonna write it one more time. Y equals mx plus b, right? It's an equation that is solved for y. This was already solved for y. So what I'm getting at is if we look at number 2, it's not solved for y. So if it is not solved for y, the easiest thing to do is to go ahead and do that. So my equation is 2x plus 6y equals 6. My goal is to get this y all by itself. So it's just no different than solving for any other variable. We ask ourselves what's happening to y, and we undo those things. What's happening to y? I multiply by 6, and then I'm adding 2x. That's according to the order of operations. We learned all this stuff in the very first chapter of the year, right? So my first step would be to subtract 2x from both sides. So I'm subtracting 2x from both sides, and that cancels out the 2x's here. When I do that, my result becomes just the 6y on the left, and then these are unlike terms, right? 6 and negative 2x are unlike terms, so I have negative 2x plus 6. You could also write 6 minus 2x. Doesn't make a difference. Last thing is to say, well, what's happening to y? I have to, y is being multiplied by 6, so I have to undo that by dividing by 6. So the thing about this is I have to divide everything by 6, right? So not just the 2, not just the 6, but both of them. So I write it individually. The other thing is that when we have our slope, we always want a simplified fraction. So let me simplify this. 6 divided by 6 is just going away. This doesn't go away. It's 1, right? We get a 1y here. Negative 2 over 6 really gives me negative 1/3 as a simplified fraction. 6 divided by 6 is 1. So now that I've solved for y, and we did that really slowly, now that I've solved for y, I know that my m is negative 1/3, and my y-intercept is positive 1, which that coordinate point would be 0, comma 1. To move myself here. So now I go ahead and graph that, right? So my y-intercept, positive 1, go up to 1, graph my point, and my slope is negative 1/3. So my rise over run directions, if my slope is negative 1/3, rise over run, what that means is I go down 1 and then right 3. Down 1, right 3. Down 1, right 3. And again, like it's only half the line, right? So instead of going down 1, right 3, down 1, right 3, I have to use it exactly backwards to get the other half. So up 1, left 3. Up 1, left 3. And that's how I graph my line. So there you have it, ladies and gentlemen. That's how you use slope-intercept form to graph a line. I have a couple more examples here. So go ahead. Actually, probably be a good idea if you pause the video right now and try these on your own. This is what we would do if we were at normal school. We would pause the video and have you try these two because they're the same as the last one. So try that on your own. I'm going to give you a chance to pause. Okay, now that you've tried it on your own, Let's see if we're able to do it here. All right, slope-intercept form. Remember, y equals mx plus b. I probably already wrote that like 6 times. Remember, this is my slope. This is the y-intercept. And so if I pick it out of the equation here, I know that my slope, my m value, is -2 because it's attached to the x, right? So -2. And I'm going to turn that into my rise over run directions. Just writing myself a note there. My y-intercept is 4. Okay, so that is the coordinate point 0, 4. So I go up to 0, 4, which is 1, 2, 3, 4 right here. Then my slope is -2 over 1. So my rise is a -2, which means I go down. So down 1, 2, right 1, down 2, right 1. And I keep doing that over and over again until I get a line. And then again, they go the other direction. We use it exactly backwards. So up to left 1. And there's my line, ladies and gentlemen. Cool, cool. All right. So again, hopefully you tried this one. This one, again, is not solved for y, right? We need to solve for y in slope-intercept form. And so that means I'm going to get this y all by itself. So what's happening to y? It's being multiplied by a -3, and then I'm adding a positive 2x to it, right? So the last thing I said was add a 2x. So the first thing I'm going to do is subtract 2x from both sides. When I subtract 2x from both sides, the 2x's on the left will cancel out, leaves me with just the -3y is equal to -2x plus 6, or you could have written 6 plus -2x or 6 minus 2x, doesn't make a difference. Then what's happening to y? I'm multiplying it by -3. I have to undo that with division. So I'm going to divide everything by -3. Then again, we simplify fractions, right? -3 divided by -3 is just y. -2 over -3, negative divided by negative is positive, so we get a positive 2/3. And then 6 divided by -3 is 2. So what do we got here? My slope, my m, is 2/3. My y-intercept is 0, -2. So now we graph. 0, -2. Boom. Nailed it. My slope at 2/3, which means I rise 2 and then go to the right. 1, 2, 3. Rise 2, right 1, 2, 3. Keep doing that. And then exactly backwards the other direction. Down 2, left 3. Down 2, left 3. And there is my line. All right, so hopefully you're getting the hang of that right now. If you're not, then there's probably a contact time that you need to sign up for. Just reach out to your teacher if this is something that's confusing to you, because this is one of the more important things that you need to understand. So let's make sure we get that knocked out, okay? All right, moving on. Okay, so now we're going to flip the script a little bit, and we're going to change this into kind of a lesson where we how should I put this? We start taking away some of the information that we would normally give you for graphing, and we still are able to write an equation in slope-intercept form, okay? So for instance, check out example number 5. It says, write the equation of each line in slope-intercept form, right? Well, we're given the slope. Awesome. It goes right in my equation, right? But I'm given a coordinate point. I'm not told the y-intercept is this, okay? But we are told that 0, 8 is on the line. Okay, that helps me. So what do I know? Well, every time I start out a problem like this, if I know I'm going to write it in slope-intercept form, right? Then I just start out y equals blank x plus blank, because I know I'm going to have to fill in those blanks. All right, well, what do I know? I know that -3 is my slope, right? -3 is my slope. And upon further inspection, 0, 8 is actually a y-intercept. You might have said that right away, and you're like, Mr. Fastback, why are you playing this game? And it's y-intercept. Yeah, you're right. Okay, so this is our y-intercept, right? 0, -8. I'm sorry, 0, 8. Which means my y-intercept is 8. So I actually do have everything I need to know to write this equation. And so there's really no work to be done here, but we are pushing in that direction. So just hold on. That means my equation then is y is equal to -3x plus 8. Okay, so pause the video right here. Do it. Try it on your own. Welcome back. I know you didn't pause it. That's okay. All right, what do we got here? We know the slope is 1/2, and we know a point on the line is 0, -4. Well, so just from last example, we know that any point with 0, comma, a number, right, is a y-intercept. So that's what we got, right? Again, I'm still operating under that idea. We start out with these problems, y is equal to blank x plus blank. Then I fill out what I know. Well, I know the slope is 1/2. I know my y-intercept is -4. And that's all I need to know, okay? So I'm going to write the equation y equals 1/2 x plus -4. All right. So now we're going to make it a little bit more difficult. But first, we have to understand something about points on the line. All right. In class, we had a gigantic table in which we asked you to substitute a whole bunch of x values in to see what happens with the y values, right? And that was more like a convincing activity more than anything else. I'm going to grab one point, and we're going to use that one. And it makes no difference what point I grab. I'm just going to grab this point right here. It's the point 3, 0, because it's going to be easy because it's got the number 0, but it makes no difference. So I'm grabbing that point, 3, 0. Okay? It says find a point on the graph above, this would be on the other page, that is different from your partner. This is something we would normally do in an activity, okay? And my point that I chose is 3, 0. Now here's what we're going to do. We're going to substitute this point that was on the line. By the way, this is not a y-intercept, right? It's some other point. Happens to be an x-intercept, but it doesn't matter. Substitute that value into the equation of the original line, y equals -1/3 x plus 1. Then simplify the right-hand side. So I'm going to do that. My y value is 0. Boom, it goes here. My x value is 3. Goes here. I'm just literally putting those values in for x and y, right? Then I start simplifying stuff. So I got 0 is equal to, and then if I take -1/3 times 3/1, what that gives me, I'm going to do the little math over here. I'm just going to write it out. -1/3 times 3/1. If I multiply fractions, numerator times numerator gives me -3 over denominator times denominator gives me 3, which gives me -1, right? So -1 goes here. So now I just got to simplify the right-hand side a little bit. -1 plus 1 gives me 0. And this is what we should be recognizing if we were to do this all in an activity for a class. Not everybody gets 0 equals 0, but everybody would get a true statement. You might get 2 equals 2 or 4 equals 4. It doesn't matter what it is. It'll be a true statement. And that is an important thing to know. What we did is we took a random point that was on this line. We substituted it into the equation of that line, and we got a true statement. That will always happen, okay? It will always, always happen. So this question here, you always get a true statement. Yep, always. You always get a true statement, okay? What we can do now is use this fact to take information that we are given and solve for information that we don't know, okay? Let's kind of see how this evolves. Now look at this one. This is very similar to the other two problems, except for check it out. That's not a y-intercept, right? 2, 5 is not a y-intercept. So let's read the directions. Write the equation of each line in slope-intercept form. All right, well, what's slope-intercept form? Y is equal to mx plus b, right? And I've started out with my traditional y equals blank x plus blank. Okay, well, what do I know? I know the slope is 3. Great. Substitute it in. Halfway done. However, I don't know the y-intercept. That stinks because before it was super simple, right? I just take that puppy and put it in there and I'm done. But I can't do it now. I have to do something else. And here's where that last part comes into play. This point, 2, 5, is on the line, okay? And notice in the last slide, we took that coordinate point, 3, 0. We substitute those values for the equation into the equation, for the line into the equation, and we got a true statement. That means we can use a point on a line to solve for something that's missing. Well, what are we missing now? We're missing a y-intercept. So what are we going to do? We're going to take a point that's on the line and substitute that in for x and y. So this is the x value that's going to go in for x, right there. And this is the y value that's going to go in for y, right there. So let's see what that looks like. When I substitute, I know, well, first of all, sorry. I know my m is equal to 3. Substitute that in already. X is 2. Literally, x is going to be, that's going to go right jaw. And y is 5. That's going to go right there. Okay? So substitution looks like so. 5 is in for y. 3 is my slope. 2 is in for x. And now I'm going to solve for b. The biggest mistake that students will make is they will forget to actually write this plus b part. Okay? They'll forget to write that plus b part. Don't forget that. Now, once I substitute all that stuff in, it's actually not too bad to solve because now it's like, all right, well, what's 3 times 2? Well, that's 6, right? And how do I solve for b? Oh, well, I just subtract it to the other side. So if I subtract 6 to both sides, 5 minus 6 is what? -1. And -1 is equal to b. Now I can write my equation because I know that my slope was 3 from before. I know my y-intercept was -1. And so I can write the equation y is equal to 3x plus 1. Boom. Okay. So now this would be another point where we would have you guys, I think, yep, we would have you like, in class, you'd try this now on your own. Okay. So pause the video. Boom, pause. Nice work. Okay, come back. All right, here we go. So again, same type of problem, right? What are we given? We're told again to write the equation in slope-intercept form. I'm going to write that again. Y equals mx plus b. Okay. Slope is -1. I don't know a y-intercept. I know a point that's on the line, though. Okay? So this is x, this is y. So again, I start with y is equal to blank x plus blank. I got to fill in the blanks. What do I know? I know that my slope is -1 from the problem, and from the coordinate point that I'm given, I know that x is going to be equal to 3 and y is going to be equal to 2. Boom, I can substitute x and y in for x and y, and I know my slope is -1. Okay, so this is what that substitution looks like, right? So that y value is in for y, so 2 is in for y. -1 is my slope. X is 3, and I'm solving for b. Again, don't forget to write plus b. Now I have to solve for b. So I have to simplify this. So 3 times -1 is -3. And that's now going to give me 2 is equal to -3 plus b. And all I got to do is solve for, extend the page a little bit. Now I got to do is solve for b by adding 3 to both sides. So what do I end up with? Add 3 to both sides. I get b is equal to 5. So what do I know now? I know that my slope was -1. I substituted in that coordinate point 3, 2, solved for my y-intercept, and I got my y-intercept to be equal to 5. So I was able to write the equation then, y is equal to -1x plus 5. Special appearance by my mother-in-law. All right. So hopefully you got that knocked out. And if you needed to watch that again, you can go watch it again. It's a video. It's got a reverse, whatever. Is it reverse anymore? It's not a rewind. It's not rewind. You just scroll back. I don't know what it is. Just go back in the video, watch it again. All right. So write the equation of each line in slope-intercept form. We got to do it again. But look at what we're given. I don't have a slope. I don't have a y-intercept. So how am I going to do this? All I'm given are 2 coordinate points, right? Think about this for a second. Do we have a way of finding any of that information just given 2 coordinate points? Can I find a slope? Can I find a y-intercept? The answer to that question is yes. I can find the slope because we have the slope formula. Remember, y2 minus y1 over x2 minus x1. So now what we are going to be able to do is to write an equation in slope-intercept form from just 2 coordinate points. That's all we're going to need. So let's dig in here. All right, what do we got to do? First thing we're going to do is we're going to find that slope. We're going to use the formula y2 minus y1 over x2 minus x1, right? So I'm going to substitute those values in. I haven't looked. So this would be my first point. I'd call that my 1s. I would call this my 2s, right? So if I do that, then y2 is 13, y1 is 1. x2 is 2. It's going to be minus, right? Subtract, and then a negative 1 for my x1. 13 minus 1 gives me 12. And then if I subtract a negative, it's really adding. So 2 plus 1 is 3. And then 12 divided by 3 is 4. My slope is actually equal to 4. Awesome. All I had to do was use the slope formula. We knew how to do that already, right? So now what do? I still got to find my y-intercept, right? So in order to find my y-intercept, well, what did we do last time? We were like, okay, we have a slope, right? And we substituted in a coordinate point. Well, we're actually at the same position that we were last type of problem. The position we're in is we know the slope, except for we're given not one coordinate point, we're given 2, right? Here's my advice to you. Pick one of these coordinate points, but pick the easy one. It doesn't matter which one you use. It makes no difference at all. You will get the same answer. Because we know that if I substitute any coordinate point into the line, I'll get a true statement no matter what, as long as it's on the line. So I'm going to pick the point -1, 1. So pick one point to use. I'm choosing -1, 1. And when I substitute all of that stuff in, I know my slope is 4 because I just found it out, right? My x value from the coordinate point is -1. My y value from the coordinate point is 1. So there it is, all substituted in its glory, right? My y value is 1. Slope is 4. -1 is my x value, and I'm solving for b. Okay? Again, just to kind of reiterate here, remember y equals mx plus b. I just took all of this stuff, right, and substituted into that formula accordingly. Now I just got to simplify, right? So 4 times -1, -4. All I got to do now is add 4 to both sides. And when I do that, I know this looks kind of sloppy towards the end here, but I'm adding 4 to both sides. This says 5 equals b. All right. So now all of that work, what was I able to do? I was able to find my slope was 4. My y-intercept was 5. And again, that's all I need to write the equation y equals mx plus b. So there it is. Y is equal to 4x plus 5. All right, I know that probably blew your mind a little bit. That's a lot, kind of a lot of work. But really, it's just this, right? Given 2 coordinate points, write the equation in slope-intercept form. 2 really big key things you got to do. First thing, find the slope, use the slope formula. We've done that before. Second thing is, use the slope, pick one of the coordinate points, substitute all of that stuff in for y equals mx plus b, and solve for b. You're done. It takes a while, but it's not that bad of a process. Okay, again, pause video. Boom, 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 pausing. I know you are. You guys are awesome. Okay. All right. Hopefully you tackled this on your own. Let's see how you did. First thing you're going to do is find slope, right? Extend the page here a little bit so I don't have to keep bouncing back and forth. So again, y2 minus y1 over x2 minus x1. So that would be 18, right? Minus 4 over 3 minus 1. 18 minus 4 is 14. 3 minus 1 is 2. 14 divided by 2 is 7. So that gives me a slope of 7. All right. Now, remember, all we got to do now is pick a coordinate point and substitute that x and y into x and y for slope-intercept form. Again, write it one more time. Y equals mx plus b. The x and y go in for x and y. How novel of an idea, right? So pick one point. I'm choosing the point 1, 4. Again, you can choose either one. Doesn't make a difference. So now I know my slope is 7 because I figured it out. I'm choosing my x and y to be 1 and 4 respectively. And now I'm just going to, again, substitute that stuff into that formula. All right? Looks like 4 is equal to 7 times 1 plus b. Well, 7 times 1 is 7. That's simple. 7 plus b, how do I solve for b? Subtract 7 to both sides. 4 minus 7 is -3. I'm going to get rid of these things here. And so my b is -3. All that work, what do? We found out that my slope was 7. My y-intercept was -3, and that allowed me to write the equation y equals 7x plus -3. Now, again, don't lose sight of the fact that all of this means that if I were to graph that line, it's going to be really tough for me to graph just because it's drawn. But let's say my y-intercept was here, right, at -3. If I were to graph this line, I would go up 7, right, 1, and this is my line. I don't have a whole lot more to write points on here. But the point 1, 4, if we look at this, 1, 4, is it reasonable to think that 1, 4 is on that line? I'd say so. And 318 would be way up here. I think it would also be reasonable to say that 318 is on that line. Not reasonable. It is. We did the math right. Nice work. Long distance like that. Cool. You rock. All right. So, a couple of contextual problems here, and then we're done. So, determining solutions of equations in two variables. Let's read the directions. Identify the slope and y-intercept of each linear situation and determine what they mean. Then write an equation in slope-intercept form and use it to solve the problem. Here we go. For one taxi company, the cost, y in dollars, of a taxi ride is a linear function of the distance, which is measured as x. I'm sorry, distance in x measured in miles traveled. The initial charge is $2.50. And the charge per mile is 35 cents per mile. Write an equation in slope-intercept form. So whenever you're asked to write an equation in slope-intercept form, again, you kind of always think about this y equals blank x plus blank, right? In this one, you're not like going to have to do a whole bunch of crazy calculation. Here's what you got to think about. What is my starting point? And how am I changing that, right? How am I changing from there? Your starting point is always going to be your b value, okay? And how you're changing is going to be your slope. So that's what you just need to think about. What's my starting value? How am I changing that value, okay? So what's my starting value here? Well, my starting value is $2.50, $2.50. How am I changing that value? Well, it's 35 cents per mile, and the miles is x, right? So this is 0.35. So I know then that my slope is 0.35, my m value. My y-intercept is 250. Boom, there's my equation. And now I can answer questions like the next one. Find the cost of riding a distance of 10 miles. Well, if x is miles, what that means is that 10 is going in for x. So let's do it. Scroll down a little bit here, extend the page. So there I am substituting in 10 for x. 10 times 0.35 gives me 3.5. And then I just have to add that to 2.5, which gives me $6. What does that mean? It means that it would cost me $6 to ride 10 miles. That's what it would mean in context. All right. So let's move on to the next one here. A local club charges an initial membership fee as well as a monthly cost. The cost, C in dollars, is a linear function of the number of months of membership. Write an equation in slope-intercept form. But in this one is different, right? We're not given anything. We're not like the last one. We were given some pretty detailed information. We were given a start, we were given a change, and we were able to write an equation pretty quickly. But we're just given a table here, right? So it's like, well, how do I start? Well, this is actually just like a problem where you're given two coordinate points. Right? This is a coordinate point, and that's a coordinate point. Well, what did we do before? First, we had to find slope. Then we found the y-intercept. Let's do it. Find the slope. Okay, my y2, I didn't label it this time. I didn't give you oh, that's not what I wanted. Undo that. Okay, that's better. That's a small little mini heart attack there. No big deal. All right. Okay, going back into this. Finding the slope. So what I was saying is that I didn't write out what the slope formula was. You guys should know that by now. I'm just saying that this is my ones and this is my twos. So this is my first point, second point. So my y2 is 277. My y1 is 100. My x1 is, my x2 is 3. My x1 is 0. So when I'm doing the subtraction here, 277 minus 100 is 177. 3 minus 0 is 3. And when I divide that, I actually get a nice number, and it's 59. I found my slope to be 59. Now, here's the thing that's interesting. I actually don't have to do any work to find the y-intercept. Why? Well, one of the points is 0, comma, a number, and that is a y-intercept. Okay, and I actually have that written here. 0, 100 is a y-intercept because it's, in that form of a y-intercept. So that means my y-intercept is 100. So what did I learn? I found out that my slope was 59. My y-intercept was 100. So I was able to write the equation out of there. Sweet. There we go. Y is equal to 5x plus 100. All right. Last question here, and then we're done. Now we're going to use that equation to find the cost of a membership after 4 months. Well, X is the number of months here, right? So 59 times X is the monthly membership fee. So 59 is the monthly cost of a membership. So X is 4 in this case, membership of 4 months. So there I am substituting in 4 for X. 59 times 4 gives me 236. Then I'm adding 100 to that, not 400. Oh, I made a typo and I went with it when I was writing this. My bad. This should be 100. I'm going to scribble that out. 100. Okay. I thought this should be 336, right? And then what does that mean in the context? That means after 4 months, it's going to cost not 636, but $336. All right, ladies and gentlemen, remember there's a video, so if there's anything here that you needed to go back and see again, just go back and see it. One last reminder, this is one of the more important lessons of the year. So you got to be solid on this. If you're not solid, sign up for contact time, send an email, and set up a personal meeting time so we can get you on track. All right? Hope you all have a great day. Peace.